we already know that n is a Poisson process with parameter lambda, and the probability of the number arrive in T1 from T2 equals k, simply equals e to the minus lambda times T2 minus T1 times lambda T2 minus T1 to the power of k divided by k factor. And we also know that xt equals to 1 if n is odd in 0 to t, and xt equals to minus 1 when n is even in 0 to t. The first question is we have to find the probability of xt equals to 1. In this case, the probability of xt equals to 1 simply equals the probability of the numbers arrive in 0 to t equals to k, and k is even. And now we should have to transform the formula to some form that is e to the power of minus lambda t times lambda t to the power of k factorial. And that is k equals to 0 to 4 and a lot of values that should be 2k and even. When we have to find out this answer, we have to use some series of the Euler formula and from the Taylor series. In the Taylor series, we already know that e to the power of lambda t equals to 1 plus lambda t plus lambda t squared divided by 2 factor plus 3 factor lambda t to the power of 3 plus lambda t to the power of 4 divided by 4 factor. And similarly, e to the power of minus lambda t equals to 1 minus lambda t plus lambda t to the power of 2 divided by 2 factor minus this part plus this part. In this case, we call this formula 1 and call this equation 2. When we add these two equations, we have e to the power of lambda t plus e to the power of minus lambda t simply equals to 2 times 1 plus lambda t to the power of 2 times this form. And now we can simply know that the form e to the power of minus lambda t k factor when k equals to 0 to 4 to 2k equals to 1/2 times e to the power of minus lambda t plus e to the power of lambda t times e to the power of lambda t. And the answer should be 1 divided by 2 times 1 minus e to the power of minus 2 lambda t. And that's the answer of the first question. Now we have to find the second question. That is, we should find the expectation of xt. In order to find the expectation of xt, we should firstly find the probability that xt equals to minus 1. When we have to find this answer, we can simply do the equation 1 minus equation 2, and similarly the answer should be 1 divided by 2, 1 plus e to the power of 2 times lambda t. And now the expectation of xt simply becomes 1 times the probability of xt equals to 1 plus minus 1 times the probability of xt equals to minus 1. And now we got the answer that should be minus e to the power of minus 2 lambda t. And that's the answer of the expectation of xt. The third question is we should find the answer of RT1, T2. When we have to find the RT1, T2, we should firstly know some very important factor, that is the RT1 T2 actually equals to the expectation of XT1 times XT2. Since XT1 XT2 should only have two results, one is 1 and the other is -1. So in this case, when RT1 T2 equals to 1, that should become from XT1 equals to 1, also XT2 equals to 1, or XT1 equals to -1, XT2 equals to -1, 2. And if the answer end is -1, there should be XT1 equals to -1, XT2 equals to 1. Or XT1 equals to 1, XT2 equals to -1. And when we see from the diagram has been given to us, we can simply know that the probability that RT1 T2 equals to 1 can simply be seen that equals to the probability that in T1 T2 the number k is even, and this part is the probability that in time from T1 to T2 k is odd. And in this case, we can kind of simplify the question, and the question just becomes the probability of XT1 T2 equals to 1 minus the probability of XT1 XT2 equals to -1, and that should be the probability that the number in T1 to T2 equals k and k is even, minus the probability that the numbers from T1 to T2 equals to k and k is odd. Then answer should be 1/2 times 1 plus e to the minus lambda T2 minus T1 minus 1/2 times 1 minus e to the minus T2 minus T1, and that should be e to the power of -2 T2 minus T1. In this case, we have made an assumption. The assumption is T2 happens after T1. And when T1 happens after T2, the answer should be simply transformed from this one to e to the power of -2 lambda T1 minus T2. So RT1 T2 equals to e to the power of 2 lambda T2 minus T1 when T2 is larger than T1, or equals to e to the 2 lambda T1 minus T2 when T2 is less than T1. And that should be equals to e to the power of 2 lambda times the absolute value of T1 minus T2. And now we can see that RT1 T2 is actually related to T1 minus T2. When we call T1 minus T2 the absolute value become tall, we can see that RT1 T2 is a WSS process. And that's the answer of the question D. Now we have formed the 4 answers of this question. That's all.